All right, so now let's take a look at differentiating some functions when the variable is up in the exponent. So logarithmic differentiation is going to be especially helpful in these circumstances. And the reason for that is because I'd like a way to get that exponent down, right? So using log laws is going to allow that to happen. All right, so what we're going to do is we're going to take the natural log of both sides right off the bat. So we'll say the natural log of y is equal to, and then the natural log of x to the power of x. So you can see right here the advantage of using logarithms is that now we can use the exponent law and bring that down. Okay, so we'll bring x down to the front. So we've got the natural log of y is equal to x times the natural log of x. And then there you go. So now this is similar to things that we've done before. So I think this is ready to take the derivative of. So if we take the derivative of both sides using implicit differentiation, then we get, so the derivative of natural log of y is 1 over y times y prime. Okay. And then that's equal to, so this is the product rule. So if we're calling this f and this g, then we'd have x times the derivative of g would be 1 over x, and then plus, and then it would be the derivative of x, so 1 times just g, so natural log of x. So my x's cancel there. We get 1 over y times y, y prime rather, is equal to 1 plus the natural log of x. Okay, and then I'll just bring this y up. So we got y prime is equal to, and now it's y times 1 plus the natural log of x. And now we're pretty much done, but we'd like to have this in terms of x, not this y, right? So let's just go back to our original equation. And if we want to write in terms of x, then y is equal to x to the x. So we'll say y prime is equal to x to the power of x times 1 plus the natural log of x. All right, let's take a look at the next one. So same thing, we're just going to take the natural log of both sides. So the natural log of y is equal to the natural log of sine x to the power of x squared. And now we'll bring the x squared down. So natural log of y is equal to x squared times, the natural log of sine x. So we are ready to take the derivative. So using implicit differentiation, we get 1 over y times y prime is equal to, and then we have a product rule scenario again. So I'm going to call that f, and I'll call this one g. So now we have x squared, which is like our f, times the derivative of g. So the derivative of this would be 1 over sine x, and then times the derivative of the inside, right? So the derivative of sine is cos. So times cos x. Okay, and then plus, now the derivative of f would be 2x, and then just times g. So then natural log of sine x. All right, I'm just going to call this y prime over y for a minute. And then I'm just going to collect my cos and sine. I'll call that cotan. That's pretty much all I'll do on this line. So x squared times cotan x plus 2x times the natural log of sine x. All right, so now I think we're ready to multiply, just like bring the y up. So we get y prime is equal to y times, really just all of this again, x squared cotan x plus 2x natural log of sine x. All right. Now, instead of y, we're going to write it in terms of x. So just, going back to our original equation, sorry, this one. We're going to say y prime is equal to, so this would be sine x to the power of x squared times x squared cotan x plus 2x times the natural log of sine x. All right, now the very last thing that you might want to do is just, you can see that I've got a common x in this. Technically, we probably should pull that out too. So then we'd have y prime is equal to x, and then times sine x, and it's just the sine x to the power of x squared. And then what we have left is just a single x cotan x plus 2 natural log of sine x. Okay, and that's good enough. Doesn't look that pretty, but that is the derivative.